Okay, that's at 1,000. We're bringing it down to 800. 700. 600.
575.
575.
Oh, there we go. 550.
550.
525. And then 512. Go up.
Oh,
It's gonna go. Okay.
Yes.
The x-axis is called frequency ratio. The frequency ratio is simply rotor running speed over natural frequency of the system. So when the frequency ratio equals to 1, the rotor speed coincides with the natural frequency, and this is where the rotor responses is high. If the frequency ratio is less than 1, the rotor is spinning below its natural frequency. In this region, the vibration amplitude increases with speed. If the frequency ratio is greater than 1, the rotor is running faster than the natural frequency, and the response starts to decrease as speed increases. Understanding this plot gives you deep insight into what factors influence rotor behavior and why design decisions like stiffness, damping, and balance are so crucial. So what factors influence the natural frequency of a shaft in a rotating machine? The natural frequency is primarily governed by the shaft geometry and material properties. From the governing equation, we can see that increasing shaft stiffness by either shortening its length or increasing its diameter raises the natural frequency. These changes improve the shaft resistance to bending and deformation, enabling it to operate more stably at higher speed. The natural frequency of the shaft or rotor can be experimentally confirmed through impact testing. And the impact test can help to identify the bending mode shapes as well.
Care must be taken to avoid as far as possible the critical speeds. Now, what do we mean by this term, critical speed? Well, this refers to a specific speed at which very high vibration occurs due to natural resonance of the turbine. If the rotor is allowed to run for any length of time, even a few minutes, at a critical speed, the vibration would be great enough to probably shatter blades and perhaps other components. In order to avoid this situation, we must pass as quickly as possible through the critical speeds during the run-up. But what are these critical speeds? Well, as our rotating mass is made up of several rotors, for example, the high-pressure and low-pressure turbine rotors and the generator rotor, we may have several critical speeds. The specific speeds will be indicated by the manufacturer. And in fact, the run-up curve provided will make sure that the rotor is not allowed to dwell at any one of those speeds. If you have an automatic start on your machine, no doubt the run-up